Sentence and document embeddings. In this chapter, we are dealing with longer unit of text if we compare with what we were studying in previous videos, which were mainly word level or concept representations. Of course, this comes with additional challenges. And as you can imagine, modeling sentences and documents is crucial for language understanding. And because of that, it is very important that we study it in detail. Of course, there are many problems associated with this unit of text that we didn't encounter before. And this is what we are going to mainly see in this video. So in this video, it's going to be an overview of the different paradigms in sentence embeddings, mainly unsupervised and supervised. Then we are going to move to longer unit of text, which are mainly document embeddings, and see what are the main differences with modeling sentence embeddings. And finally, I'm going to give you just some short hints on what are the main use cases of sentence and document embeddings, and what are the main applications and how you can evaluate them. So what is the goal of sentence embeddings? In a nutshell, what we want is to get a vector representation of a whole sentence. So instead of having a vector representation for smaller units, such as words, as we see in previous chapters, in this chapter we are going to see how we can get these representations with similar properties that we discussed before. Like, we want also to be low dimensional, so we can also do more computationally demanding tasks, and getting also like similar sentences will be close in the vector space. Taking all these properties into account, what we want is to get a vector representation for a single sentence. So how can we do that? So in this example, we have the sentence, "It is cool." The idea is that you can work with the components of that sentence, in this case, for example, with the words, and you can come up with a representation that takes everything together and outputs just a single vector. So here there are many ways to do that. One key element that we are not going to discuss a lot is compositionality. Compositionality means that we want to compose smaller units into the larger units that is the sentence. For example, here we have like the vector average, but we are going to see that there are others as well. In this chapter also, I want to highlight that we are not going to spend a lot of time unlike the other chapters. This is not the key topic of the tutorial, but hopefully it will give you an overview, and you will have also some key references that then you can check yourself if you want to get into more detail. So let's get into the core of the question. And there are two different kinds of sentence embeddings, roughly, that are unsupervised and supervised. Let's start with the unsupervised, which, as you can imagine here, what we're going to use is only like a single corpus that is not labeled to learn this sentence representation. The first idea is quite simple, is that I was mentioning is with some back of words approaches, where we can just get representation of the words and then do kind of operations on the vector representation of the words. And some example of these are traditional like frequency-based or TF-IDF like vector space models. We can also have some simple composition over the word vectors, where some may work better than others. And one very simple technique that has been shown to be very robust and be difficult to beat is like a simple word embeddings average. So you get the word embedding of each word in the sentence, and you just average them. This has been proved also to be very, very robust. One of the main drawbacks of all these approaches is like most of the time they disregard word order. And as we know, in language, word order is important, at least in many tasks. You will not understand correctly the meaning of the sentence if you don't capture well the word order. And to solve this limitation, there have been different approaches, and some of them are based on prediction or classification, and globally with a sentence level training. There are also other approaches that are based on transformer-based language models and contextualized embeddings. We are not going to discuss this in this chapter, and for this you can check the video of the contextualized word embeddings as there are more information on this and how they work. So let's move to the sentence level pre-training. Roughly, there are two different approaches, as I mentioned. One is prediction-based approach, and the other is a classification-based approach. The prediction-based approach is basically, it's been framed as an encoder-decoder architecture, where you have a sentence, it is snowing today, and the goal is to predict the next sentence. I might go skiing this weekend. As this idea, they can give you already quite a big indication of what is the meaning of the sentence. As if you know a sentence, you more or less can predict what is going to come next, or at least having a rough idea. If you train that over millions of sentences, you get something like a meaningful representation of the sentence. A popular approach is called skip thought, that it was rolled in 2015. It works exactly like this. In this case, it's just the encoder and the decoder is based on an LSTM, but of course, you can replace LSTM with any other neural network architectures, and this will also work. And then, more recently, there is a classification-based approach that comes with some advantages and also disadvantages, of course. In this case, the goal is not to predict the next sentence, but actually you will have some options, and you will have mostly a classifier when you have to select the correct sentence. So, of course, here, you need to get some negative samples, and there are different ways to sample them. But in a way, this is a kind of more natural for a neural network that many times, as we know, or at least in NLP, they work quite well, no, in classification tasks, no. So this is in a way is a kind of a simplification of architecture, but the idea is it's roughly similar. So what you have to classify is also the next sentence. One example of this architecture is the quick thoughts that it was proposed in 2018. So what's next? We discussed unsupervised sentence embeddings, but as usual, every time that we have unsupervised, we have also a supervised version where you can actually take into advantage of extra information and not only use the information of an unlabeled corpus. As I mentioned also, these methods is not that they don't make use of an unlabeled corpus, as they do as well, but they also take into account of all the information and maybe some other tasks when you have labeled data. This is the case of these approaches that we just here put some examples when you can use language inference data, you can use matching translation data, and in this case, a parallel corpus, for example, or actually ground it in something like vision. That is also something very interesting in NLP, no? So to ground language into vision, and this can give us also additional insights. And finally, why not? You can just combine different tasks into a single architecture, like what we call also multitask learning. And this can also help get improvements. As perhaps, as you may think that one of the single tasks, it will going to focus on one particular aspect in language. But if you can encode many different tasks into a single architecture, this can be even better. So this is all for the sentence embeddings part. As I say, it was kind of a high level. I gave you also some references, so you can just check them out if you are more interested in that. Now I want to move to the document embeddings. Here what we want to say that in many cases you can just take a sentence embeddings approach and extend it to paragraph and documents. Of course, this may or may not scale well, not only in terms of complexity, but also because, I mean, obviously model a document that is longer is not the same as model a sentence. So for that, many times you need actually some more targeted approach. And in this case also, it's worth mentioning that back of words baselines, as I discussed before, is even stronger in the case of document embeddings. As many times in the document, what you care about is like to model what the topic is about, but not having this fine-grained distinction. And many times also the word order doesn't matter. That is important, no, in the sentence embeddings that we discussed. Other techniques, very common, is based on LDA, topic models, no, where you can get a representation based on these topic models. Or just making operational word embeddings, as similar to what we saw in sentence embeddings. And here we have some common approaches that has been presented based on that, based on, for example, word embeddings based on word2vec or any kind of other word embedding. You just make operation, and you can actually kind of predict the topic or have a proper representation based on just those smaller units. So finally, why we want sentence or document embeddings? What is the application and how we can evaluate them? So here is quite simple to explain, but obviously it will take a lot of time if I just describe all the tasks that you can apply, because basically you can apply it in any tasks where you have sentences or documents, no? Anytime that you have a sentence or document, you can just model the sentence or the document as a sentence or a document embedding, and then you can have even then a classifier on top of that, or a neural network, no, that take into account those embeddings as input. But realistically, in what kind of tasks we use? So mainly in tasks where you have, they are computationally very demanding. So you cannot, for example, have pass towards a large neural network architecture, because that will be very time consuming and not efficient at all. So for example, in clustering or retrieval tasks where you have to make a lot of operations, you can just make them based on these embeddings, and that will be much faster and convenient. And that's why also, as I mentioned, with the word embeddings, the lower dimensionality that the sentence embedding have also is generally an advantage. And how can you evaluate? So there are some kind of unified benchmarks that they include many different heterogeneous tasks, like here, for example, Centeval or glue and super glue that we also saw in the contextualized embeddings video, or many classification tasks in general, like text classification is a or document classification. They are very popular tasks, and they are the tasks that are very commonly used, not to evaluate sentence or documents embeddings. And that will be all for this video. Thanks for listening. Bye.